We now keep going farther east across the Atlantic Ocean to the UK for our next presentation that is going to be given by Hilary Shields about a redevelopment project in the UK. Hilary, the floor is yours.
Okay, thank you, and thank you for inviting me as well. This is about foundation reuse at 2 buildings in London, 65 and 67 to 69 Whitfield Street, which you can see in the picture on the right here. The client was Derwent London, the architect was Make, main contractor was Multiplex, the engineer, and we were also innovative, was Arup. I'm Hilary Shields from Arup Geotechnics. My co-author is Joanne Sainsbury from Arup Structures, and the 2 directors who were involved was Jeremy Edwards on the structural side and Dinesh Patel on the geotechnical side. So an overview of the project. So the site is located in London, in central London. It's about a mile away from Euston and King's Cross St Pancras stations, in an area of London called Fitzrovia, and it's surrounded by 4 roads, which are Charlotte Street, Howland Street, Whitfield Street, and Chitty Street. So this is the area of the site, and this is what it looked like before the new construction. So essentially 2 areas of the site. The pink area was designated the commercial area of the site for office, to be redeveloped for office space, and the green areas of the site, they were to be redeveloped for residential accommodation. So you can sort of get a feel from these figures around the edge. The commercial area was predominantly blocks from the 1960s. Initially, it was intended that those structures and the foundations would be reused, but the final scheme in those areas was for demolition and new build, apart from the facade of 71 to 81 Whitfield Street, which was retained, this facade here. And but the 2 buildings in the residential areas, this is 65 Whitfield Street, which is this one here, and 67 to 69 Whitfield Street, they continued for foundation and superstructure reuse throughout. So there is a slide coming which illustrates this, but essentially the 2 buildings that were going to be reused, they were being enhanced with additional floors, and so this is a summary of the redevelopment that was required. So, but both of them had an additional floor on the roof. Both of them were partly demolished with new build extensions. The 2 additional floors, lightweight systems in both places. The facades were retained. There was a reconfiguration of the cores and the stability systems. Beneath the new superstructure, there were board piles into the London clay. The 2 buildings had different foundations. So the 65 Whitfield Street, which was built in about 1955, that was on board piles into the London clay, and 67 to 69 Whitfield Street was built in about 1930. That was on deep pads found at about 3 meters down on the terrace gravels. And the main difference between these 2, or key difference between these 2, is we needed to add strengthening works in the form of mini piles to the reuse at 65 Whitfield Street, whereas we managed to justify full reuse, as is the 67 to 69 Whitfield Street. And both structures required strengthening works to superstructure as I mentioned, the commercial scheme at 80 Charlotte Street was originally foundation reuse, and it was adjusted partway through when a new build scheme became preferable for market reasons. So this is just a diagram of that list that I just gave. So here you can see the two new floors and a new a replacement of the existing roof for both these structures. The purple elements are the portions of the existing structure that were retained and reused. The red areas are the areas that were demolished and had new build. There was some new infill superstructure in this green bit, and at 65 Whitfield Street there was also some new first floor structure in white. So this was just to give you just an idea. So on the left, this image here was actually taken when they were constructing the commercial area, where they basically demolished the buildings. They deepened the basement slightly. This is when the new core was coming up. But you can see this is 67 to 69 Whitfield Street at the corner of the site. Actually, by the time this core was being built here, they'd actually built the additional superstructure, the infill structure, in this for this building. This is just a diagram, a schematic of the construction when they were building the commercial area. Here you can see the retained frame of 67 to 69 Whitfield Street in the corner here, and this is the retained facade that was kept when the decision was taken to demolish the rest of the structure. And on this corner here, this is 65 Whitfield Street, just coming off the picture here. So an overview of the timeline. So both these buildings, 65 Whitfield Street and 67 to 69 Whitfield Street, they were buildings within the conservation area, and they weren't listed, but they had sort of local heritage, and people were very fond of them. So a cost value analysis in 2011 identified reuse as the most cost-effective strategy. The planning application went in 2011, and the permission was granted for upgrading them and reusing them. At the time, there was limited information about the existing structures and foundations, so a load balancing approach was adopted. With lightweight construction proposed for new floors. Actually, originally Arup favoured a laminated timber scheme, but ultimately it wasn't actually adopted, so the eventual solution was slightly heavier. There was always some possible column strengthening included in the cost estimate for 65 Whitfield Street. Foundation strengthening was a risk item at that time. It was considered unlikely with a load balancing approach, and we thought we would be able to find more information on the foundations than we eventually did. For these old structures, the stability system was unclear, and the core arrangement wasn't appropriate for the residential use. So new core areas and surrounding floors were proposed as new build. So in 2012-2013, we started the structural and geotechnical investigations on the site. The structural investigations broadly confirmed the expected superstructure. However, it was realised that that strengthening works were required on the superstructure at both buildings, and also on some of the slabs at 65 Whitfield Street needed replacing. The geotechnical investigations broadly confirmed the expected pad foundations for the earlier building at 67 to 69 Whitfield Street, and piles for the 1955 building at 65 Whitfield Street. In the phase 2, 1 and 2 ground investigations, we couldn't fully verify the foundation size and depth, so a third phase of investigation was required to demonstrate that. At 65 Whitfield Street, the phase 1 and phase 2 investigations, and the picture was unclear following those, but we knew enough to realise that a foundation strengthening approach was required, and further investigations were required in a phase 3 of investigation. Following the phase 2 ground investigation, as I mentioned, the commercial area at 80 Charlotte Street was altered to new build. I think the market conditions changed. They could build new build faster than strengthening and adapting all those various old structures around the site. Plus, they could have a deeper basement. And the phase 3 GI enables finalisation of the design and strengthening work solution. So just an overview of the foundation reuse design approach. So in the UK, we have various guidances, which have some of them been around for a while now. We have the Rufus Proceedings of 2006 and the Syria report, Reuse of Foundations, in 2007. They're quite substantial documents. Shorter guidance, there's a BRE paper on drivers for foundation reuse, and more recently in this year there's a guide written for the Institution of Structural Engineers Climate Emergency Task Force by my colleague Henry Taylor, who I believe is also been invited to join today, so thank you. So the guidance in all these documents is about understanding and minimising the risks associated with foundation reuse. So the key elements to think about in a reuse strategy. So the risk-based approach is developed early using desktop research, and that desktop research, is key. The important thing is to manage client and insurer expectations from the output, because from the outset, I mean, because the process of development of design thinking and cost as the project goes forwards is much more complicated than for a new build. It's important to clarify the ownership of risk with a risk matrix. So identify what are the risks to the client. The site is his, the information about the site is his, inherent defects are his. On the other hand, we as engineers, we are designing with the best knowledge we have, and there has to be a clear division between those aspects that we are responsible for and the things that we can do nothing about, which belong to the client. It's important to target investigations on the site as early as possible, and explain to the client that actually, there may need to be more investigation as a result of what you find in the first one. For instance, in our instance, we ended up with 3 phases of investigations. You need to allocate risks on a foundation by foundation basis, and you have to mitigate those risks on a foundation by foundation basis, including considering strengthening options. The costs are defined as the project progresses, but the early investigations enable a good handle to be obtained on those costs, but it is an ongoing decision-making process, and the residual risks get closed out through monitoring during construction. So this is just a sort of a chart to illustrate that process, so the certainty of information on the old foundations increases with time as you go through the project. So right at the beginning, there need to be discussions with the client so he understands the process. Then you have a phase of desk study and making a preliminary assessment of reuse, and in that time the structural teams will be doing an existing and a proposed load takedown, and the assessment will be made of the viability for that reuse. Then then the investigation will come in, and that will include investigation for soil parameters, but also intrusive investigation into the foundations to understand their geometry and their durability. And again, that's typically more expensive than a conventional ground investigation, and that will enable an evaluation to be made of the reuse scheme and the risks and whether strengthening is required. And potentially there's another second phase of investigation, and eventually the reuse scheme is justified, potentially with strengthening works, and then you get to the construction phase where you can close out residual risks with monitoring. Of course, during this process, it may be that actually that foundation reuse becomes not viable, and then but with client buy-in and client understanding, that can be managed. So at 67 to 69 and 65 and 67 to 69 Whitfield Street, I wasn't going. This is our strategy flow chart. Wasn't going to go through this. It's just to illustrate the process of decision making that we went through. But actually, the interesting about our project was that the desk study for existing foundation information was not successful. We did not find the information we expected to find on the foundations. So the decisions we took relied heavily on the existing realistic loads. We were trying to adopt a load balance as far as possible, and investigation to understand what capacity we thought we had, or we understood that we had, and this approach was reviewed by both building control and the client's insurers. So site investigation. So really, in the context of this topic for increased testing saves money, the key elements of increased testing were these 3 phases of site investigation. So I was going to explain those so you can understand the complexity of what was involved. Although at the end of the day, we did manage to succeed in reusing the foundations and the superstructure of these buildings. So this is a picture of the phase 1 and phase 2 ground investigations. Actually, at that time, they covered the whole of this commercial area here. They covered the whole of the commercial area. They cover 67 to 69 Whitfield Street in here, and they cover number 65 Whitfield Street in here. And essentially, both phases consisted mainly of pits to get down to the underside of the pile caps, and boreholes to investigate the geology, and boreholes with parallel seismic testing to investigate the lengths of the piles. In phase 2, we also had a ground radar penetration scan of number 65 Whitfield Street, but it was done through the existing ground floor slab, and it really wasn't successful. And we also had various probe holes through the slab in 65 Whitfield Street to try and map out the foundations. This is an example of the geology. that we encountered. So this is a typical sequence in London, central London. You know, we've got some depth of made ground. Actually, that varied considerably across the site. We have river terrace deposits, which also varied in level and depth and consistency across the site. The main bearing stratum in this part of London is the London clay. It's a heavily over-consolidated clay. It's a great material for founding board piles in. And then underneath that, we've got the Lambscrew and Thanet sands and the chalk. We actually zoned this site, although we didn't because we were trying to reuse the foundations everywhere. We didn't in the end in the commercial area, but we had a stratigraphy that we finally adopted at 67 to 69 Whitfield Street and at 65 Whitfield Street. The London clay possibly looks quite conservative here, but this London clay was slightly less strong at the surface in this area, so we adopted a profile which captured the capacity of the piles that we would actually achieve. So just an example of these pits and the parallel seismic testing of which we did numerous pits. So just this is an example of a pit, and this is the borehole for parallel seismic testing that was carried out in that pit. And this is the pile that we exposed. It's been repaired, but there was a core taken here for strength and durability of the existing concrete. And here, this pile's been repaired here because a small notch was cut in the pile head. And with this parallel seismic testing, you cut a small notch in the pile head and you lower a receiver down your borehole and you strike the pile as this is lowered at half-meter intervals. And you can see a change in response when you go past the toe of the pile, so you can interpret the pile toe. This was the GI specifically at 65 Whitfield Street. These little squares, they're the column locations around this basement. And in the phase 1 and phase 2 GI, we had several pits with those boreholes with parallel seismic testing throughout the basement. And from that, we identified pile lengths, approximate number of piles, but we found that the geometry of the pile caps was varying. And in the phase 3 investigation, we had lots of pits, but they were more aimed at understanding the geometry of the pile caps for our strengthening solution. This is an example of the pile and the pit at TP 123, which is in the basement of 65 Whitfield Street. So here you can see in this particular pit, we found 2 piles. We found this pile again, that's a core taken into the pile. We also found another pile by probing into the corner of the pit. But it also understands the complexity of trying to construct this pit in a basement which was live. You know, we put up hoarding but it was successfully done. And this is another example in the basement of 65 Whitfield Street. We managed to map out the edge of the cap using these small probe holes through the slab, and you can see where we thought the edge of the cap was. Then we dug the pit. We could see we had a rectangular cap, a rectangular pile cap. We found a pile underneath. And you can see the borehole for the parallel seismic testing there. So this example of interpretation for that particular pile cap. So here are the, this is the factual data that we recorded. We measured the diameter of these two piles, 440 millimeters diameter. This is for the pile we found by excavating sort of from the bottom of the pit to probing sideways. This is the pile cap in section, and this is the interpreted dimensions for the pile cap for our proposed strengthening works. So this is just to give you an example of how, you know, the complexity of trying to understand the capacities of these foundations and the risks associated with reusing them. So just on the left, we didn't reuse these piles in the end in the commercial area, but we did have one test pile from the original scheme, and this was the geology, you know, the made ground, the terrace gravels, the London clay. But look at the variation in level of the London clay and penetration of the piles that we actually found. So we were actually busy zoning that site before it got before the scheme changed. But here at 65 Whitfield Street, you can see the main bearing stratum here is the London clay, because the effective stresses in the gravels, you know, are quite low because we're not very deep. So, you know, here we were just getting 2 or 3 meters into the London clay, pile diameters for 440 millimeters. We wondered, could the caps be taking anything? But actually, in the gravels beneath the caps, there were soft clay layers. So we deduced that we couldn't take anything significant in cap bearing. So in the end, we decided that there was no distress to this building whatsoever, but we could really only justify the foundations at 65 Whitfield Street for the existing realistic load. And then at 67 to 69 Whitfield Street, actually we were quite limited in what we could do in phase 1 and phase 2 GI. We had a couple of pits in phase 1. We had some dynamic probes and a borehole with a core in phase 2, but that really didn't define the extent of these pads. So we had extensive pits and probing and coring against every column and every pad in the phase 3 ground investigation. Sorry, it's taking a while. Try again.
Jamie, can you move to the next slide?
Yeah. So this is an idea, just to give you an idea of the geometry we finally proved for the pads beneath 65 Whitfield Street, and this is just a picture of these pits, and you can see, you know, they were considerable excavations. They were 3 meters deep. This is the pad down in the bottom of it, and well supported all round. They were so that, you know, that was quite a considerable undertaking to construct those pads. We did lots of for those pads. We did lots of cores and strength testing to so by coring through the pad, we understood the depth of the pad. We could understand the pad capacity. We could understand the strength of the concrete, and we could carry out petrographics for cement content, chloride and sulfate, and for understanding of concrete durability. These results actually pretty high strength, in fact. But there was some honeycombed concrete which our structural team needed to think about. So this is about the foundation design and strengthening. And I'm sorry, I'm realizing I'll hurry through this. So the foundation design strategy at 65 Whitfield Street, we decided that we had sufficient factor of safety on the existing foundations because there was no sign of distress in the existing building, but that for new loads above those existing realistic loads, we needed to strengthen the foundations because we didn't have foundation design or construction information. We found low pile capacities, we found variable pile lengths, there was uncertainty of the numbers of piles beneath each cap. So we actually assumed that the response of the existing piles to the new load might have potentially softened by 50% when the building was stripped out. So when we strengthened the foundations, we assumed that as we increased load back up to that existing realistic load, 50% went into the existing and 50% into the new piles. we designed the new piles so that all load that was going onto the new piles could be taken with a full factor of safety, and we made sure that actually the new piles had a factor of safety of 1.5 on the full new design load in order to ensure that settlements were small. So 65 Whitfield Street. So basically we had new board pile foundations beneath cores and new structure, which was 600mm diameter. All piles are about 18 meters long, and for the strengthening works we had a mixture of 250mm and 300mm diameter mini piles, and the mini piles were constructed around the existing foundations where we could get round them, and either side where we were in the edge wall by the light well. So this is the strengthening works that we adopted. So where we were in the light, we're in the light well. So there was a. This is the old retaining wall of the building. This is the light well area, and eventually there will be, or there is, a new wall to the building with a window built in here. And here we installed new mini piles either side of that existing column, and we gripped the columns with this steel transfer beam so we could take load out to the pile foundations either side, so that as this structure took up more load, these piles out here would start to take up load. And in the middle, what we did was we put 4 mini piles around the edge. I think you can just probably see the central bar of the mini piles sticking up here. And we connected them into a collar which went all the way around the edge of the cap. So the cap sat down into that collar. So as this load was increased on this column, load went into the cap, but the cap then transferred load out to this collar that it was sitting in, that put load into the piles around the edge. So and both these solutions, a lot of detailed thought from our structural engineers went into these. 67 to 69 Whitfield Street. We were load balancing with existing realistic loads as far as we possibly could. Where we had increases that were greater than 10% of the existing realistic load, we checked the factor of safety on the ultimate bearing capacity with a load spread of 45 degrees through the pad. We also actually did a sort of a ULS check with a load spread of 1 in 2 through the pad, and structurally the pads were checked for concrete strength in accordance with Eurocode 2, and also the junction between the steel column and the pad was also checked. And the analysis concluded that the footing concrete was adequate. We analysed settlements of all these footings. They were small, and so we were able to adopt the reuse. And so that was finally closed out through monitoring. We had a detailed monitoring specification. I won't go through these risks, we're running out of time, but we did have careful monitoring of the movements to ensure that they were acceptable. We had a detailed monitoring specification. We had small trigger levels of our amber level was 5, our red level was 7 millimeters on settlements. And you can see that this is 67 to 69 Whitfield Street. You can see that we stayed within our predicted movements. We monitored every single column. Similarly, at 65 Whitfield Street, you can see that we stayed within our predicted movements. And so the conclusions. So it was hugely complex, but ultimately it was viewed as successful. We saved these structures for the future. It was a team approach. We had client buy-in. We had integration of structural and geotechnical teams. The early investigation allowed for the costs to be defined throughout the project. defects insurance is required. We did have an early type of piling, which with limited codes for understanding of the design at the time. The load balance approach was the best solution. You know, we needed to allow for extensive increased ground investigation and intrusive works, and the same actually applied to structural investigations. We had complex design thinking to justify the old pad foundations at 1670-69 Whitfield Street. We developed innovative systems for the strengthening at 65 Whitfield Street. Detailed monitoring of the structure was required during construction, and there were significant carbon savings. So sorry for running over a little. That's the end. So thank you for listening.